Hello, my name is Zoan Kobayashi. I'm a member of the Laboratory for Advanced Visualization and Applications at the University of Hawaii at Manoa. This video is a code introduction to making apps in SAGE2. What this covers is related topics that should be considered during development, a brief review of the system architecture from a code perspective, a basic JavaScript primer pointing out major differences from other languages that may cause confusion, major files and folders in the installation directory, differences between hosted and native apps, a brief review of an app skeleton, and a basic review of a working app. This will not cover how to install Sage, the requirements to install Sage, or usage of Sage. Related are certificates needed for remote site sharing, but it will not be covered in this. Some things that should be known ahead of time is a solid understanding of object-oriented programming. SAGE2 is primarily written in JavaScript, and understanding HTML and CSS will greatly help, but the majority will be JavaScript for app development. Deployment machine should be Windows 10 that can be reached through wireless. Windows 10 is recommended because the binary is built for Windows. While you can use Linux and Mac, you will go through additional steps and need to ensure that the dependencies necessary to run Sage are installed on your own. There is a how-to on the Bitbucket page, but do keep in mind that it will take longer to set up than just Windows. You'll also benefit by having basic concepts and understanding of client-server interaction. These are not required, but it will help because Sage is basically a server and a client. Git will also be preferable because you'll be working with source code. SAGE2 is a web server, so it runs on top of Node.js, which will host web pages, among other things. Users will connect to the user interface page, and they will see the content that's on the wall to the display client page. Now, commonly, the host system will be a single PC, and its monitors will connect to the display client, or rather, they will connect as display clients. And users will have their own laptops that connect to the user interface page to interact with the wall. SAGE2 requires a modern browser. If you have the binary, it will come with Electron, ready to launch. Actually, even in the source repo, Electron will be referenced as part of the dependencies, so it will require a couple additional steps to launch if you're using Mac or Linux, but it is available as part of the repository. A bit of clarification. Electron.js is needed to run the display clients in order to enable some functionality in SAGE2, for example, the web view, which enables you to view web pages within the SAGE2 workspace. On the right, you might notice the E icon. That is for Edge, not Internet Explorer. We don't really recommend Internet Explorer. So a top-level description of SAGE2. There is a Sage server, and that will connect to many clients. Typically, you'll have at least one display client, one audio manager, and multiple user interface clients. Connections are not required, and they can be duplicated for display and audio. On the display layout, that is the display clients and how they view into the workspace, it's always a rectangle. So one of the things is that the display resolution must be uniform. Inside the config file, when you specify a display's resolution, this is assumed to be the resolution of all connected display clients. So mix of physical monitor sizes and resolutions are not recommended. It is possible, though, if you do always use the smaller resolution so that the high resolution displays at least will be able to see everything, as opposed to if you use the high resolution, then the small monitors won't be able to show everything for their particular tile. Each physical display will then be directed to access a particular display client ID starting at 0. The ID corresponds to a row and column within the layout, but they do not have X and Y value. It is just 0 up to the total number of displays. So when filling out the config, do keep in mind the ordering that you use to assign display client IDs. The other thing is that while resolution must be uniform, display client IDs can have additional width and height units representing how many tiles in the system they take up. So if you have a mismatch of monitor resolution, size, and it is possible that if you have, say, multiples, the larger ones are multiples of the smaller ones, you can make the larger display clients occupy more than one tile space. Some of the effects of this setup is that the server can be active without clients. And in fact, when you first start the server, there shouldn't be any clients because the server is going up. And a client is basically a web browser connecting to the server to access their particular client page. User clients can connect even if there aren't any display clients, but this isn't recommended, and there are a couple issues that might occur, although usually it's a matter of, you should have the displays active before users can interact and so they can see what they're doing. Now, display clients are identified through URL parameters. As mentioned before, there's the display client ID, so again, they are connecting through a web browser, so to have them know which piece inside the workspace that they are going to display, they need to request a particular page that corresponds to that position, so the server knows how to correctly give them where they should be showing. Now, display clients, again, because this is a web server, display clients can exist across different physical systems, so you don't need to have all the display clients on one computer. It also allows mirroring, so you can have two different browsers pointed to the same URL. Now, display clients can also ask for a client ID that doesn't exist, but nothing will show because the server will just say, well, that ID doesn't exist, so there's nothing for me to give you. It is also not necessary for all display clients to be using all the display client IDs. So partial setups are possible. A couple examples is maybe you want to test something, you don't want to start all your monitors and displays. Now, server will not die when connections are lost, so this is also one of the benefits is maybe you had an internet connection interruption or something happened that required a computer to restart. So it is also possible to allocate more tiles than physically available. And the main purpose I've seen for this is to stage an area where people can upload without interfering with what's being shown on the screen. Up next is the JavaScript primer. And JavaScript is similar to other languages. It has a lot of the same core concepts, variables, functions, objects. And I'm going to say that it's like C in that it'll let you do whatever you want, even if it's wrong. But unlike C, Java is pretty good about not hard crashing, and it has a pretty good error reporting as well. Another clarification is that Java is not JavaScript, two completely different things. Now, when you test code in JavaScript, it usually means you're running your code in a browser. So if you are, or rather when you are developing apps for Sage, you will probably need to have the Sage server active, connect to it through a browser, then launch the app to see what happens. Both Firefox and Chrome have good tools. They have different strengths, so you might want to check them both out. And do keep in mind that when you write JavaScript code, not all browsers have the same set of JavaScript implementation. Now, modern browsers need to comply with HTML5 standards. So typically, if you want to make sure your stuff works across platform and browser, use HTML5 standard stuff. But that being said, all of the browsers, or nearly all of them that I'm aware of, have some extra stuff that are specific to that browser. Typically, the best documentation page is developer.mozilla.org. When you use JavaScript, your script files must be staged. So this is similar to other languages when you import or include. But in this case, on the HTML page, you will need to have a script tag that states every script file that is to be included. The reference path is with respect to the invoking page's location on the server. Now, all the scripts that you are including are executed in that order. So it's not get them all, load them at the same time. It's grab one, load it, execute it, grab the next one, load it, execute it. So if you have scripts that refer to other, functions or variables that are in another script file, make sure that file is used first or stated first. Otherwise, you might run into errors. or rather you probably will if it's dependent on it activating beforehand. Now, variables that aren't scoped, as in inside curly braces, they all occupy the same space, and that is global. Now, JavaScript is single-threaded, so all web pages are single-threaded. A browser is multi-threaded in that if you have multiple tabs or windows, and even for its own core functionality, it will be multi-threaded. But a single web page is only given one thread. So if you ever do a loop, make sure they stop. Loops will halt everything. That includes visual and input from the user. So if you do a loop expecting input from the user, you're probably not going to get it because the page needs to have access, or rather it needs to have time so that it can check for the input. The loop will halt it and it won't be able to check for input. Sometimes there's a little confusion between asynchronous and multi-threaded. Asynchronous does not mean multi-threaded. So the functions setInterval and setTimeout, they are asynchronous, but that does not put them in a different thread. So they will still use the same thread that the web page has been assigned. Now, up next is an example of a piece of code that is valid, but it will lock. So I have variable I, and it's set to false. I create a timeout, and what it does is that after 1 second, I will be set to true. After that is a while loop. So while I is false, do nothing. And the idea is that the set timeout will probably activate after 1 second, so that it will eventually check out that I is not false, and then you get to the last statement, which is printing I is now true. However, this code locks because the while puts a lock on the code. It will never be able to properly handle the set timeout, and so even though 1 second has passed, set timeout didn't get to update, so it's stuck in this while loop, and console.log will never activate. JavaScript variables aren't type restricted, so when you declare them, they don't need a type, and the initial value that you give it to them doesn't restrict their type either. There are 5 immutable values: Boolean, null, undefined, number, and string. Really, it mainly applies to the string. So when you perform any of the functions of a string, it will not alter that value. When you assign it a value or make modifications to it, you are now working with a new and different string as opposed to whatever you started with. Anything else is an object, so they're going to contain memory references. As an example, if I have variable I and I assign it 0, it's not going to be restricted to numbers. I can later assign it 1.1, so a float. I can then also assign it string, boolean, null. So these statements all in a line are all valid. There is also the JSON object, or rather, I should say, when someone says JSON, they are referring to the JavaScript object notation. So really, it's a JavaScript object. But JSON more specifically refers to how you use to define an object. Files with .json are files that comply with how to syntactically define an object. So a JSON object is really just a JavaScript object. So the following is a notation on how to initialize an object. I have variable declaration, and it needs 2 curly braces to note that it's an object. And within, I define 2 properties, age and name. So age is assigned the value 10, name is assigned child. I can then print it, object.age is 10, object.name is child. So there are many ways to initialize objects. The most basic object is the empty object. So when you first declare it, it will have nothing inside of it. Now, all objects can be modified once they're made. So in this line, variable object is the empty object, meaning there's nothing in it. It is still an object, so if I try and access the name attribute, it will return undefined. And then if I try to access a non-standard attribute field, it will still be undefined. However, if I then say object.name is then equal to string JavaScript object, and object.notStandardAttribute field array 1, 2, 3, they will be created as attributes and assigned. So the above is, all of this is legal. And this is how a lot of mistakes get made with spelling mistakes. So you might assume or mistype something, and if you're assigning it, it'll then be created and added. Or if you are off by a capitalization, then that causes problems too. So if you are trying to access something and it doesn't exist, and you're certain that it exists, or you're assigning something and when you recall it later, it doesn't have that assignment, make sure the spelling is correct, because there's a good chance that it might have been the wrong spelling. Up next is functions. Functions mostly work the same as other languages. One of the primary differences, parameters don't have types because JavaScript is typeless, so you just give it a name to work with. And the keyword return is not needed. And actually, functions don't have to state whether or not they return anything. So here are examples where I have the function add, and it takes two parameters, x and y. It's going to return the sum of the two parameters. Then I have another function, add without return, x and y. It prints x and y instead, the sum, that is. So then I have variable a. It's going to be assigned the value that add 1, 2 returns, which is 3. But I can still say a is going to be assigned add without return 1, 2. Now, the function as part of the console.log will print 3, but a will then be assigned undefined because it didn't return anything. So any function that is not defined with a scope is global. And functions can be given more or less parameters than specified. Just keep in mind that if you need that parameter, it may cause problems. So if you give it less, that particular variable will have the value undefined. But if you give it more, it can still be accessed through the keyword arguments. Well, actually, it's a variable called arguments that can be reassigned. Generally don't do that. Important to know is that functions are actually objects with a little bit weird scoping. So the other thing is that function names are variables. They can collide and they can be overwritten. So if you have a function called add, and then you say add is equal to something, you've just overwritten your function. Functions can be assigned and passed as values by excluding the parentheses. So this is one way that you can pass a function as a parameter, or you can set object properties as functions. You can also set variables as functions. Now on to SAGE2 folder organization. In the install folder, there will be a number of folders and files that are of main importance to app creation. First is the root of the folder, wherever you installed it. Then there's config folder. These will contain example config files for other sites that are in usage. Main thing to keep in mind for that one is how the displays are set up, resolution, tiles, layout. Next is the key folder. So the server must have keys generated to allow users access to the user interface page. Up next is the Sabi.js folder. This one will contain the Windows control panel code if you download the binary. Now, in terms of the actual code for the Sage server, that is in server.js. In addition to that, it also has support files in the src folder. So again, in the SAGE2 installation root folder, there will then be the public folder. And the public folder is where all the clients will connect to, or rather, that's where the web pages will be served from. So inside of that is the index.html and the display.html. So the index is for the user interface client page, and the display.html is for the display client page. The formatting is a little off here. So inside the public folder is the src folder, the images folder, and the uploads folder. The src folder contains additional JavaScript files for running the backends of the clients. The main thing inside the images folder is the background, which then contains the SAGE2 background image. So that's the background on the display clients. Inside the uploads folder, there are other folders, but the main one is the apps, which contains all the app folders. Up next is implementation considerations regarding user input. So on the user interface page, users can interact with the wall. Now, commands sent from the user interface page are usually specific. So you scale an app by a certain amount, you move an app to a certain location, you launch or close apps. In addition to that, you can start a pointer. Now, the pointer is not a real pointer. It's just an image representation of where the server believes it should be. And this matters a lot because on the display client, again, JavaScript isn't really designed for multi-users. So that pointer is really just an image. And when you interact with an app, say with the mouse or the keyboard, when you move the mouse, you click a button, push a keyboard button, the user interface client will send that event to the server, and the server will then check what app is under it and then tell that app a key was pressed or a mouse button was pressed. Now, the data that it sends are not actually JavaScript events. They're SAGE events that the native apps are then able to handle. SAGE2 native apps are apps that will run directly on the wall. So they're actually objects that are in charge of their own specified area. So the window outline on the wall. Now, they are capable of affecting anything else because, again, everything's in the browser, but you shouldn't be doing that, or rather avoid it as much as possible. But keep in mind that some of the things that are common which will overlap with others are global variables, global functions. Try as much as possible not to do things like that in the off chance that it does collide with something else. But this also extends to things like modifying the HTML page, so CSS, creation of divs, or ID of divs, tags, etc. When you're making variables, as much as possible, try and use that objects, or the app object, and add it to the app object. Display clients are segregated. They know nothing about other displays. So if you have two display clients active, they are incapable of knowing exactly what's going on in the other display client. They only have a guess because of what the server tells them. Now the server, while it tells display clients to run things, launch things, close things, and sends pointer events and user interaction, the server doesn't actually know what is happening inside of an app because the app is running on the display client. And while you can have apps save and transfer data, the server still generally doesn't care about that data. It is being told to save it or transfer it, and that's all it does with it. So when you have an app that accesses other sites, be it because you made a script reference to an external location or you're using an API, do keep in mind that as many display clients as you have, that's how many times it's going to access the site. Communication occurs between the server and display client, usually from server to display. Communication between server and clients are done through WebSockets. So the client code uses the variable WSIO, that stands for the WebSocket input-output. And it's not quite a standard one, so it has been modified to work a little bit better with SAGE. So there are some automatic conversions and error reporting. An example of using it is WSIO.emit packet name. So that's a packet. It needs a handler for it, and the actual data. So between the server and the display client, the packet name must exist as a handler, otherwise it will either be not sent or discarded on being received. WebSockets allow the server to just arbitrarily send data without having web pages request for more data. Now, typically, apps probably do not need to use WSIO, but it's good to be aware about this. In addition to native apps, there's also hosted web pages that can be accessed through SAGE2 WebView. Now, the page must be hosted, and not all aspects are available. For example, you cannot upload file select, you can't use drop-down menus, or rather the native core browser drop-down menus, and you can't right-click. Right-click is being fixed at the moment, so eventually that will be available. And the reason why you can't do uploads or file selects is because that part of that is it will open a new window as part of the browser action. But the thing is that the display client is on a different system. So when it opens a new window, you're going to have to go to that system, use its mouse to click on it, and if you're working from your laptop, that's not where the file is. So a couple design considerations when you make a hosted web app is that the app should scale. When you're working with SAGE2, you're probably using a tile setup, so there's going to be a lot of resolution. Text needs to be readable. Interaction items have to be large enough to prevent frustration. So location matters on high resolution, both because of where you put it, the size of it, but also because of how much movement you need to do. So if you are going to make use of the entire wall, and your controls are, say, always on the left side, but your main interaction area is on the right side, and you are forcing the user to move the cursor back and forth, that's kind of tiring. Now, here's the pros and cons for using hosted web pages. Pros is that it's comparatively easy, since you're probably going to just use regular web page standards, and whatever workflow you have, it's very minimal changes from that. So there's a lot quicker setup. The cons is that you're going to need to host the page. Not all the features are available. For example, a good number of events, mainly because, again, your app is being hosted inside of another app. So we have to do some translation, and not all the events will make it. Anything that pops up a new window will not work as well because, again, it's probably on a different system. Interaction will be incapable of differentiating users, but that's part of natural JavaScript. So the main issue with that, though, is if you have a, say, click and drag effect, and then there's two people with pointers over it. When one person clicks and drags, the other pointer will cause issues with it because there's not going to be two locations transmitted as part of the mouse move. It is segregated from the SAGE2 system, so it will not have access to as many information variables or data about what's going on in the display. Also, random can really mess things up because every web view is going to have a separate instance of random, and that easily makes things out of sync. Now, when you use a native app, there's a good number of pros and cons as well. So pros is that you will have a higher level of control, the states can be saved, you can utilize the SAGE2 API, although realistically you have to comply with the SAGE2 API. But it enables things like communication and syncing between remote sites. So the cons, of course, is you must comply with the SAGE2 API. Interaction is usually explicit in nature. As mentioned before, when someone does a mouse move or key press or something with the SAGE2 pointer, it's the app that's getting a SAGE2 interaction event. It's not a JavaScript event, so you're going to have to deal with it. So because of these things, you must comply, and interaction is explicit. It'll usually take longer to make, also to get used to things. Before starting to write a native app, there's a couple things to consider. First is the name. The name must be unique from any other variable. The apps are really objects, and the objects need to be stored somewhere, and that's the name that you give it. So the name is going to be a composite of alphanumeric, or it doesn't have to be, but it can be comprised of alphanumerics and underscores. Generally start with an alpha. Using any other symbol or even spaces will cause problems. So when you make an app, the folder that you put it in, the entry for the instructions.js file, the primary JS file, so the name of the JS file, and the variable used at the top of the primary JS file must all match. If any of them don't match, the app probably won't work. Actually, the folder can be different, but for the sake of keeping everything consistent, just use all the same name. If you want to see any examples, just go to the installation folder, the public uploads apps, and take a look there for the apps that come with Sage. This is a SAGE2 native app skeleton. You can find this on the Bitbucket location, the address specified here. Now, before we start, I want to bring attention to these A, B, C, D, E, F, G markers because they are pointing out a couple things that are kind of important for consideration when you first start writing. So at A, this is going to be the top of the file. The var is the my app. That is the variable that I was talking about that needs to match the file name, the folder name, and the entry in the instructions.js. So that needs to all be the same. Up next is the init. So when your code, or rather when you're defining the app, which is, this is a skeleton piece, before that you can see the sage2.appExtend. So the init here is going to be the first function that will activate in what you define. But keep in mind that this is extending the SAGE2 app, so there are going to be, in addition to what's here, other variables and other functions. And the SAGE2 app will have a couple other functions that activate first. But out of the code that you write, the first thing that will happen is the init function. For part C, you can see that there's a this.resize event, and above that is a this.sage2 init. But it's really pointing out that there are variables that already exist as part of the SAGE2 app. So, but in addition to that, some of the variables have further meaning that you can modify after creation. So in this case, the resize events is continuous. That means that anytime the app is resized, this function down here, resize, will be called. There are other choices that you can make, and there are other properties that can be altered. So again, visit the Bitbucket for more, this web page at Bitbucket for more information regarding the other properties. Now, part D is this.myValue. So this is actually where you would be creating the variables that you need. Again, this is kind of abusing JavaScript object in the sense that you can just arbitrarily add properties to an object. But again, this is also how you will be adding your variables, so it's kind of necessary. In part E, there is a this.log. Log is one of the functions that are defined inside the H2 app. So it has specific functionality behind it, and just do keep in mind that there are functions that are available in the app. Again, take a look to see what's there based on the web page. Not all of these are necessary. Part F is actually kind of important for the sake of reducing errors and in case your stuff doesn't work right off the bat. Each of these, so init, load, resize, event, move, quit, these are properties on the object, and they're properties that are defining functions. So this needs to comply with JSON notation. So this comma here is really what's being pointed out. It's the lack of comma here and the comma that is right here. So when you are adding more functions or other properties, just keep in mind, don't forget that comma, because it will cause things just to not work. It has to comply and be correctly syntaxed. Finally is G. This is a curly brace, a parentheses, and a semicolon. So this curly brace is actually closing the extend function here, or sorry, the object rather, that is being sent to the extend function. This parentheses closes the function call, and this semicolon ends the statement. So actually this entire thing is one statement. Focusing on the init function, this will be the first thing that activates in the code that you define for your app. Now, as part of the init function, what you should be doing is defining a layout, creating all necessary variables, and doing whatever it is you need to set up, because this will occur before the first update cycle on the wall. Now, part of it is that it also must call the SAGE2 init function. So this particular function, as mentioned before, the init isn't the first one, but this SAGE2 init is what you will use to communicate to the SAGE2 app class anything else that you might need that's relevant, or certain things that you need to modify before it actually starts and does its thing. Another thing that I want to point out rather is this is the init function, but you will be able to use any of the other functions that you define within the file. So as a way just to keep the code clean, don't hesitate to create more functions and call them and use them. So the load I'm actually going to skip over because this is more related to remote site syncing. And the main thing to keep in mind is that if apps are to be shared across sites, you need to make sure you know how much data is being transferred, what data is, and this load function will then come into play then. But I'm going to skip that for now. The draw function is actually called at set intervals, and there is a SAGE2 app variable called maxFPS that will limit how much the draw function is called in a second. There is no way to guarantee a minimum value because, again, JavaScript is single-threaded, and actually just like any other machine, if you give it too much to do, it's not going to be able to meet a minimum value. But the maxFPS will hard cap it on how many times it will activate within a second. So standard coding practice is to use time as a means to calculate rather than every update do a very specific amount, because again, depending on how much the display client is stressed in terms of needing to do work, there's no guarantee on the minimum. But typically this is where the so-called update function will occur. When you resize the app from the user interface page, or if you use a pointer or someone else does it, this function will be called. So this is one of the things where one of the earlier properties right here is that question is when will it be called, and usually it'll be called at the end of the resize for the sake of saving computation and not spamming the function, so to speak. Now with continuous, it'll be every event, every movement. So do keep in mind that there are ways to update the function. The main purpose of resize is if you need to redraw it or recalculate the layout. So or move things because the size has changed. Again, this is SAGE2 app, so there's a good chance that people will be manipulating the size a lot. The event function will be handling, or rather it will be receiving, whatever the server sends it when it believes that a cursor or the user interface is sending events that should correspond to the app. So this is where you get it. You'll get the type of event, where the position of the cursor was, which user did it, what data is regarding the event type. So was it a keyboard, what key was it a mouse, which button was it, or was it a movement kind of thing, how much did it move. Date will then correspond to when the server got it. So again, as mentioned before, the interaction is explicit. You have to deal with the data yourself. Now, much like the resize function, the move function is called when the app is moved. And in this case, there is another variable that will control how much it gets the events, or rather to restrict how often it gets the events. But another thing is that, or rather the main thing behind this is that should the app move, does anything special need to happen? And in most cases, it doesn't need to do it, because usually apps will care about how big they are, not so much whether or not they're moved. Finally is the quit function. So sometimes you want to save the data, so anytime you want to save the state, or one of these things where you need to do cleanup, anything like that, the quit function is always called before the app closes down. So when from the user interface you have your cursor over an app, you hit delete to close the app, the quit function will activate first. You can do whatever code you need to do here, and then the app will close. Do keep in mind that if the server is being shut down, there is no guarantee that the quit function will activate. Alright, so now for an app. This is an example app, and it is an example timer. And first up, we're looking at the instructions.json file, and then I'll get to the script itself. So as mentioned before, inside of the instructions.json file, the main script, example timer.js, that name must match the name of the script file and should match the name of the folder. And at the top of the script file, when you have the variable example timer, they should all match. In addition to that, you can have an icon for your app. Time.png is my icon, and that's this clock thing here. I gave it a width, I gave it a height. So these are the starting values for when they are put on the wall, or rather when they're launched. Animation true is actually whether or not the draw function gets called. So if animation is set to false, then the draw function will not be called. But typically for apps that are updating, animation set it to true and use the draw function as an updater. I gave it a title, example timer. I give it a version, a description. I'm leaving out keywords because, again, this is just an example, so I'm not going to keep it in there. So inside the main script file, you'll see that so there is the variable, and it is doing the extending of the SAGE2 app. And first up is the init function. So when I'm using the SAGE2 init, I'm basically telling it to give me a div, and I'm going to pass on the data. So for resize events, continuous. Another option that you can use is onFinish. So continuous means anytime that you drag and stretch the border. OnFinish means wait until a user releases the border and then call the resize event. For the element.id, this is going to be the div that the app gives me. I'm going to set its ID to div and the unique ID that Sage server has given the application. These are really just formatting. So within the div, again, this is the div that is created as part of the initiation for Sage app. I can then set its style. So these are regular CSS manipulations. Now, right here are the custom variables, or rather the variables that are specific to this app. So I'm going to be tracking the start minutes, the start seconds, the current minutes, the current seconds, and the countdown, whether or not I am counting down. Ignoring load for now because I do not need to sync this across sites. Now the draw function is being used as the update function. So if the timer is counting down, then I'm going to reduce the current seconds by this.dt. Now this.dt is one of the SAGE2 application variables that will be updated in the background. So part of the display client's background tasks is to tell the applications or rather when they draw, to draw, but also how do apps know how much time has passed. So one of the things is that the display client will fill out this variable every time before the draw function is called. So this is how much time has passed since the last draw call. So this is just logic to count down. If the seconds is less than 0, then reset it back to 59 if I have minutes left. Otherwise, then I'm no longer counting down. I'm out of time. And always update the display time after I do this calculation. So display time itself will then be manipulating with the div element that was assigned to my class. The text content, I'm just going to change it based on whatever the current minute and second should be shown. I actually don't need to deal with resize, but I kept in the thing earlier because that was part of the skeleton code. Events. So actually this isn't using any events because events are explicit. Basically, if you wanted to have it clickable, or if you wanted to react to keys, this is where you do the check. What is the event type? What is the data in this case? Or more specifically, if you're using keys, which key was it? Does it match the key that you want to do? Etc. I'm going to go through a different system, and this is the get context entries. So from the user interface, you're able to right-click apps, and this is going to be much simpler for me to show while keeping the code clean. So when you right-click on an app, you'll have a couple options. You can set the time, you can start it, you can pause it, you can reset it. And this is a description, so this is what the user will see as an entry. The callback is what function will be activated when they choose that option. Parameters are not used for now. I don't need parameters. In this case, when I set the time, I'm going to need an input field. So in this case, I'm allowing up to 20 characters, which is really a lot more than is necessary. Separator is just a line that shows on the user interface just to separate out the commands. Next up is the start command, or rather start entry, and it will call back, meaning activate the function called start timer. The pause will activate the function pause timer, and the reset will activate the function called reset timer. When you click on set time, this is the function that will activate. The parameter is a response object, so that is what it will get back from the user. The server will add a couple other things to it, but the main thing that we want from here is the client input. So what do they type for the starting time? And we're just going to parse out the pieces and put them into the corresponding minutes and seconds. And then we're going to update the time display because that's what it should display for their starting time. Now, it won't start, though. It'll just be the starting time. So when you actually click on the start entry of the right click, that's when it'll set the countdown to true. Then the draw function will say, okay, we're counting down, we're going to start reducing the values. And then pause will just set the countdown to false. Reset will set the countdown to false, and it'll reset the current minutes and seconds to the starting minutes and seconds. Okay, so let's see this in action. Open here are two Chrome browsers. One is set to the user interface client, the other one is a display client. Now, typically in most setups, the something else will be connected to the display client because they can make better usage of resolution and other people can see that particular display client, but for the sake of the video, I have it open on my laptop, but also shows that SAGE2 being a server, you can access the display clients and take a look at it on your own personal laptops as well. So first is the launching of the app, so example timer. This is the one that was created earlier. So as mentioned before, there is no interaction. I didn't put any code into it, so there's no interaction capability. So again, I kind of skipped it because, again, it would take a lot of time and make the code messy. So to speed things up, I just did the right-click option. So on the app, I can right-click it, and I can set a time. So let's set it for 1 minute, or 1 minute and 2 seconds. So set to 1 minute and 2 seconds, right-click again, I can start it. Count down, and there goes. So when it reaches the end, it'll hit 0, but I'm just going to reset it. Start it, goes down to 1.9, and I'm going to reset it back to 102. Start it at 1 second, and start. Okay, and that's a basic app in a nutshell.